Hi everyone, we're going to use the principle of mathematical induction to show that the given statement is true for all natural numbers n. This is a divisibility type problem. So the first thing we want to do is show that the statement is true for when n equals 1. This is condition 1. So basically when n is 1 we have 3 to the first power minus 1. That equals 2. And 2 is divisible by 2 because you can divide that by 2. Alright, so now we want to consider condition 1 is satisfied, and we want to assume that the statement holds for some k. So I'm going to copy this down with k, 3k minus 1. Now in this type problem we're going to do a little trick. So make sure, so we're working on condition 2, and we're going to assume that it holds for some k and determine whether the statement holds for k plus 1. So we know that this right here is divisible by 2 because we're going to assume that's true. Now we're going to check for k plus 1. So get 3k plus 1 minus 1. Now what we're going to do on these type of problems is a little trick. What I'm going to do here is take this statement and write 3k plus 1 minus 3k to the little k plus 3 to the k, then minus 1. So let me show you right here. This right here, this equals 0. So what we're doing is we're just adding 0. We're not changing the problem. We're adding 0. But by doing this, it's going to help us solve this. Or not solve it, but prove it. So now I'm going to write this again. So we have 3 to the little k plus 1 minus 3 to the little k plus 3 to the little k minus 1. And I'm going to factor each piece. So basically I'm taking this piece and this piece. And this first part I'm going to factor out of 3k. When you factor out of 3k, you're going to get a 3 minus 1. Okay, and then we still have this plus 3k minus the big 1. Alright. Now, just to show you, I want to make sure you all know this. When you multiply 3 times 3k, this equals 3 to the little k plus 1. Well, I've gone over this in other videos, but you need to know this basic information there. So I can do that, and when I do that, I'm going to get 2, this is 2, times 3 to the k plus 3 to the k minus the big 1. Now, we already know that this is divisible by 2. So that checks. And this is also divisible by 2 because you can divide that by 2 because of that 2 there. So basically, we have proven that 3 to the k plus 1 minus 1 is also divisible by 2 because it's right here and it's divisible by 2. So condition 1 and condition 2 hold, and so that means that given statement is true for all natural numbers n. Just remember we did this little trick here. It's a little trick to help solve these, and if you know that and you also know this part, it makes it easier. Okay, thank you and have a nice day. Bye-bye.